Alright, so day 3 I decided to re-record with 7th period. And the reason why I wanted to I decided to re-record is the questioning that happened during 5th period this morning was awesome. It was awesome. I do anticipate the same questioning from you guys. There's a lot of bonus points up for grabs, but that other video that I recorded, seriously, I'm in the hotel room, the backdrop is just nothing but a white wall, and it's really it's very informative, very detailed, but I think it's a little bit too long and a little bit boring. So anyways, I want to make sure that your voices are on here as far as what questions did you have, so on and so forth, okay? Here we go. So which inequality is equivalent? If you move the 2x by adding it, you would be left with a negative 3x on the left side. If you subtract the 4, you would have 3. Our goal is to get x by itself. So when we divide by a negative, we flip the inequality sign, and you should have got D as your answer. Raise your hand if you got D. Nice. All right, so let's go to 2. A line with the slope of negative 3 is coming from these 2 points. So we know that the slope equation is y2 minus y1 over x2 minus x1. So if I choose from this, let's say that this is the first point that I'm going to choose from, it'll be like negative 3 minus p over 4 minus a negative 3. This is our slope. So we could have negative 3 minus p there and 7 on the bottom. And we're going to set it equal to what it said the slope was, which was negative 3. So now, what would I do to both sides to start solving for p? Multiply by 7, because it cancels to a form of 1. So I get negative 21 is equal to negative 3 minus p. This right here, the way it's written, I probably, and this is me, to you it could be different, but I would probably look at this negative p coefficient and I would add it to the left side. Meaning I would add the 21 to the right side. So you should get p is 18, which is C. Raise your hand if you got that. Now look, the hardest thing about this unit starting today, in my opinion, is that there's so many different ways to do something. You guys probably, number 2, did it a little bit differently. Just a little bit differently, and that's okay. All that experience and practice is what you need to not be afraid to make a mistake with, because you will grow from all that experience. If you don't do enough experience, and this is going to sound wrong, if you get things correct the first time you do it, one of 2 things is happening. You know what you're doing and you're getting correct, or 2, you're getting lucky. In my opinion, if you make mistakes, you learn more. That's what you kind of want to do too, but you don't want to just make full mistakes. Do you understand what I'm saying? So finding that balance, that's what you're going to see a lot today of. All right, so x squared plus 6x minus 3. We're looking for solutions, okay? So if I have x squared plus 6x minus 3, now I know you can't see this on the video, but over here to the left, I wrote this all down, and I do want you to take a picture of it. It shows all the different ways we learn how to factor, okay? And it also shows a couple of new ways that we're going to factor with things called sum and differences of cubes. Okay, so all this right here, I will leave up. In fact, you know what? I will even take a picture myself, and I will text remind it out to you guys, because this right here is a good summarization of everything that you need to know. Okay, there's a lot going on right there. So looking at this, I'm going to go through this kind of like what I would do, but again, you probably might do something different. That's okay, as long as we get the same answer. I would try to see if I could factor this out into 2 binomials. Okay? I would ask myself, what 2 terms would multiply to get this term, which is x and x? And then I would ask myself, what 2 terms would multiply to give me a negative 3? So 1 and 3 are my only factors. This is the number sense. Over here, it's the first way that I would try. So 1 and 3 would multiply to give me this 3. However, if I add it, I'd get 4. If I subtract, I'd get 2. None of these are the 6 that I need in the middle. So to me, from there, the second step that I would do is called the discriminant test. To see, am I going to have imaginary solutions or am I going to have real numbers? So I would go to b squared minus 4ac, which is 6 squared minus 4, 1, negative 3. And then negative 4, positive 1, and a negative 3 is a positive 12. So I would have a positive number. A positive number means I will have two real solutions. Two real x-intercepts. Two spots that are different where it could cross the x-axis. Okay? I just learned from here that I'm going, from here, that I'm not going to be able to do it by hand. Not by trial and error number sense. So then I would go to, in fact, instead of factor by grouping, this quad formula should be the third one, and factor by grouping should be the fourth one. I would go to the quadratic formula, which is a negative b plus or minus the square root of what we got from the discriminant test all over 2a, which is 2 times 1. 48, going for bonus points now. What would I do? I'd factor tree, it's called.
Factor up to 48.
Factor out the 48, yep. So you're going to do prime factorization with the 48. Okay, you're going to pull out primes. You could do it like the factor tree, like Charlie's saying. You could do 2 and 24, 2 and 12, 2 and 6, 2 and 3. You stop when you get each one to be prime. Remember, the first prime number is 2. So I have 2, 2, 2, 2 times 3. Okay? And yes, this 2, some of you might even see this as 16 and pull out a 4. That's perfect. That's even better. Your speed, your number sense is on point. If you don't, you'd pull this out, you'd pull this out. Each one would come out as a 2. The 3 would remain, so 4 root 3 is what that 48 would simplify to. That's simplifying the radical. So I have negative 6 plus or minus 4 root 3 all over 2. Guys, if this is all over 2, can I do this? Why? All these subtle things I want you to categorize and give it a name. Why can't I do that? Common denominator. You're just adding or subtracting fractions that have the same denominator. Okay? So this would simplify to a negative 3 plus or minus. Please make sure that you understand what simplifies. The coefficient of the radical simplifies, not the radical inside. So you should have got C. Raise your hand if you got C. Okay, here we go. So the new stuff for today, like I said, I can't stress this enough. And guys, I have no problem. This is 7th period that we're talking right now. And they did win the pizza party, which you see those 8 pizzas in the back of the room right now that we're going to eat after lunch, or during lunch. I don't mind maybe even doing another pizza party for this unit. Because I can't tell you, I cannot stress for you enough how important last unit and this unit are. To me, they're the most important units out of the entire year. And I'm not kidding. Today, cumulatively putting everything together, I would say between those 2 units, today is the most important day from those 2 units. Okay? A lot. We're going to go through a lot. There's a lot of examples. The notes are probably a full hour, maybe a full hour and 10 minutes. There's a lot going on. And I need discussion throughout every single problem, very heightened, okay? And yes, I will be awarding bonus points. All right, here we go. So the first one that we're going to look at, is this example right here. So we're going to start with polynomial equations. And it's asking, what are the real or imaginary solutions of the polynomial? Real versus imaginary. But this is the most important word. This will tell you what your answer is going to look like. Okay? What will my answer look like? X equals some stuff. we're going to list out all of our answers, like all the x values. And for this one, there will be 3 answers. How do I know that? Because that power is 3. Whatever your highest degree is, that tells you how many answers you will have. All these subtle things that I'm saying today, I'm going to offer big bonus points. The biggest bonus point that I offered today was answering, or basically asking, one question, and it's worth 300 points. Just for that one understanding, okay? And it's near the end. Okay, here we go. Everyone does things differently. So I'm going to call on 3 people. I want you to tell me what you would do. And you can be wrong. That's okay. But I want you to see the differences of what people would do. Charlie, what would you do?
I would factor out the x squared on the left side.
Okay, so he would factor out the x squared on the left side immediately. Okay? Drew, what would you do? Go to the calculator. Okay, so that's no calculator. Okay, we'll say that's the only thing. No worries.
I didn't know what to do, but I got it.
Okay, yeah, you're right. Go to the calculator. You can't, and look, this is one of the ones that we're going to do. But for today, we're going to do all non-calculator because we've got to learn the algebra behind it. Okay, but he's right. You could go to the calculator, see the graph. What would you do if you didn't go to the calculator?
Try to make A1.
Try to make A equal 1. Okay, so you're putting all your ideas. Charlie was saying GCF out the x squared on the left side. I'm telling you, there's many different things. Here's the hard part. Because there's so many different options, a lot of people, don't take offense to this, please don't. But a lot of people of your generation are afraid to make a decision. Why? Because they're afraid to be wrong. And you are robbing yourself of all this knowledge when you're afraid to be wrong. Do you understand? I can't stress it enough. I know it sounds oxymoronic as far as, that doesn't sound right. I'm serious, okay? Emily, what would you do?
I would move the 3x to the other side and then factor out an x.
Okay, so she would move the 3x to the other side and then GCF out. Okay, so from this, the A being 1 is correct if I have a quadratic, because I'm trying to complete the square. You with me? But that's not a quadratic. This is a cubic. So we're not going to do this. No worries, because now you know when you're supposed to do that. Okay? You still learn from that mistake, quote unquote. And that person's still going to get points, because that is good stuff to bring to our attention. GCF out an x squared. This is appropriate, but the timing of that can be easier if you see it at a different time. To me, I like this idea best, because out of all the different ways you're going to solve problems, because you're different people, there's so many different problems after that, that each problem you will do differently. Okay? So here we go. We will have 2x cubed minus 5x squared minus 3x, and we'll set it equal to 0. Okay? Can someone tell me, and don't be shy, again, you will get points if you're wrong, but you will get more points if you are correct. So that was team 2, team 5, and team 4. Why did I set it equal to 0? So I can factor. But why did I set it equal to 0? Some of these I don't have to set equal to 0.
Oh, it was team 1, not team 2.
Oh, my bad. So what? Why did I set it equal to 0? Thank you for that. Trying to find the solutions. This word right here says set it equal to 0. Solutions, roots, zeros, x-intercepts. Okay? So this told me, and some of you will do unnecessary work. Unnecessary work will waste time. Make sure that you understand what you're supposed to do, when you're supposed to do, and why you're supposed to do it. Now from here, Emily's saying GCF. What did you say we would GCF? An X. Perfect. We pulled out an X. Anyone? What are my scraps left over? 3. Perfect. Okay? Now, again, everyone's different. Some of you might look at that 2 here I'd say let's make that 2 into a 1 and let's complete the square. My hierarchy right here, I'm going to say try the number sense first, then try solving square roots, then try quadratic formula, or then try factor by grouping. Here we go. We're going to break up this quadratic. This x is still out here all by itself. Here we go. I need two things to multiply to give me 2x squared. What are they? 2x and x. I need two things to multiply to give me a 3. 1 and 3. Here are my choices. The reason why I set this off to the side is because I could put plus 1 minus 3. I could put minus 1 plus 3. Or I could have moved the 3 to be first by putting it plus 3 minus 1. Or negative 3 plus 1. 4 different choices. But my goal is to multiply the inside, multiply the outside, add them together, and get what number? Negative 5. Do y'all see that? A negative 5 is what I'm trying to do when I add those together. Okay? So let's go to start strategically guessing. What do you think it's going to be? 2x what? Plus 1. And then minus 3. I get a negative 6 on the outside. I get a positive 1 on the inside. And when I add, I do in fact get the negative 5 that I need. Okay? It's nice and pretty. You guys got it on your first try, which is awesome. It doesn't necessarily mean you're wrong if it didn't work out. You just have to try other options and know how to strategically find those options. Okay. This is in what form? Factored form. Here we go. My question to you is it fully factored as it sits right now?
Yes, because there's no powers greater than 1 on x.
Perfect. The powers of all these x's are not bigger than 1. So it is fully factored. There's 3 linear pieces. X is linear. 2x plus 1 is a line. And x minus 1 is a line. Okay? Alright, so now let's solve for their solutions or their roots. The zeros. What's the first one? 0. What's the second one? Negative 1/2. Yeah. And the last one? 3. And if you didn't know that, guys, you would have to set each piece equal to 0 and solve for x. This one, it's already done. Solve for x here. That's how we get the negative 1/2. And sure enough, 3 would be if you add the 3 to both sides. Okay, yes?
So the other factor, how did you get x minus 3?
X minus 3? Because remember we were trying to find what factors would multiply to give me this negative 3 right here. So, and I had a 1 and 3. We just had to figure out where does the 3 and where does the 1 go. Because right here I have 1. Right here I have a negative 6. And adding those together would give me that negative 5 that I needed. So if I set each one equal to 0 and solve, that's how I got these 3 root solutions, zeros or x-intercepts.
Why would that root be x minus 6?
Oh, because they multiply? So, you see it? I see. You see what she's saying? Why wasn't it negative 6? Well, it is, but it's because this one was different. This is not just 1. Do you understand?
So you multiply by that to get the negative 6.
Yeah. But you still factor it as x minus 3. Good. All right. So, are all those real or are all those imaginary or some, what are they? They're all real. All 3 of them are real. Any questions before we move on to our next example? Guys, seriously, we have a lot of examples to look at, and each are a little bit different here and there. you are identifying. Hopefully without having to do 30 or 50 homework problems, you can identify and ask those questions with me today. Okay, so we can do a little bit of homework. Okay, so let's keep going. Let's go to this question right here. And this question is asking us, what are the imaginary or real solutions? So it's kind of asking us the same thing. Set it equal to 0, solve for x. Okay? So let's go ahead and do what we learned last problem, the way Emily suggested, of moving that over and setting it equal to 0. How many of you would have done something that looks a little bit different than this? There should be some hands raised. What would you have done, Gina?
I thought we would have placed it in order in terms of,
Descending order?
yeah.
Perfect. That's what you should do. Okay? Savanovic, what would you do next?
Divide the whole equation by 3.
Okay, yep, they all have 3, right? They all have 3, but they all have more than just 3. What else do they have, Savanovic?
The exponents.
The x and the exponents, but all of them have 3 for sure. You're right. But help them out, Raquel. What do they also have?
They have an x squared.
They also have an x squared. This is why it's called the greatest common factor. It's the biggest thing that all of them share. Okay, everyone. What are the scraps left over? X squared minus 2x plus 4. Got to be able to do this in your head, right? Quickly to factor this all out. Most of your tests and quizzes are going to be non-calculated. By the way, your first quiz is next class, okay? So make sure you ask me a great question. And it's everything including today's stuff. Here we go. Is it fully factored? No. How do you know? Exponents that are squared, but we want all these exponents to go to what? 1. Okay, check this out. Because the things that we're saying, and I want you to say out loud, there will be some special case scenarios. Everyone, looking at this, could you factor x squared minus 2x plus 4? You can't, not by hand. Let me show you why. You're thinking, these two multiply to give me that. These two have to multiply to give me a 4. Here we go. 1 and 4 or 2 and 2. And I taught you this will either give you a 5 or a what? 3. This will give you a what? A 0 or 4. But what do we need? We need a -2. So if that doesn't happen, what I would probably go to from here, okay, I would look at the discriminant test. B squared minus 4AC. And the discriminant test gives me positive 4 minus 16. And we know that this is less than 0. And we learned from the discriminant test, and it was a question on your last test that very, very few people got, but we will continue to test you on, that you need to understand. Because the discriminant test gave us a negative, what does that mean? No real solutions. But we will have what kind of solutions? Imaginary. And here we go. Now that I know I'm going to have i's in my answer, from here, I would go to the quadratic formula. Here we go. X equals -b. Okay, and I'm talking about this form right here. Plus or minus the square root of b squared minus 4ac. Well, get this. I already did that. Okay, no sense in doing all that work again. All over 2a. 2 times 1. So start simplifying, we get a positive 2 over 2. We're going to do the what was a fancy term for the square root of negative 12? Prime factorization. We're going to simplify the radical. So, those of you, instead of doing 2, 2, 2, 2s and stuff like that, what two big numbers do you see in 12? 4 and 3. And negative 1, right? Technically. What's the negative 1 going to come out as? I. What's the 4 going to come out as? 2. Does the 3 come out? No. Because it's not in a pair. All over 2. Common denominator says all over 2a. We can actually separate out into 2 fractions. So that the most simplified form is going to be 1. That cancels to 1. So we have x is equal to this. How many answers are here right here that I just wrote? 1 plus or minus I root 3. 2 answers. Okay? Because one of them is this one. You're not alone. I had to see it like that too. And the other one is that one. And you can write them either way. If you want to separate them out or write them like combined, either way. But this one we never found the zeros to. Remember, you said we know we are fully factored when it breaks down all the way to 1. This one never did. So we had to do the quadratic formula. Did this one fully break down to 1? No. But we can still set this one piece equal to 0. Let's do algebra 1. What do I do first? Divide by 3. What do I do next? Square root. Anytime we do a square root, I've taught you should do a plus or minus. If this was to the power of 4, you would do the 4th root on each side, but it would still be plus or minus on the outside. Let me fix that real quick. You with me? 2, 4, 6, 8, 10, any even number will always be plus or minus. How many of you saw what I just did? Plus or minus. Okay, good. Alright, so this is just going to be x is equal to 0. So we have 0, we have 1 plus root 3, or I root 3, and 1 minus I root 3. But I circled on the last problem that the highest power would tell me how many answers I have. But I only have 3 answers here. Shouldn't I have 4? Yeah.
Wouldn't you have 2 variations of 0 because it wouldn't be the plus and minus 0?
Well, he's almost there. 0 is it's not positive nor negative.
Yeah,
It's neither. But the two variations that you're talking about it's a double root. You don't have to, but if you wanted to write it out twice, you could. And what does that tell us it's going to do on the x-axis? Balance. Remember? 1, I know there's so much to remember. 1 means it goes through. A power of 2 means it bounces. And 3, squiggles. Okay? There is a lot, and I'm trying to make sure that I don't lose you. As soon as you start getting lost, you need to throw that hand up, okay? Because I immediately need to find you and bring you back. Questions?
So when you solved for the solutions, how did you get it to be 1?
How did I get what to be 1?
Like, it's 1 plus I squared.
Oh, okay. So remember over here it was all over 2a?
He divided 2 by 2.
Yeah, I divided, instead of all over 2, I divided both sides by 2.
And then you took the negative 12 and then
Check this out. I'm just going to make a problem up, okay? this is the same it's a really good question that she asked, okay? Let me ask you this. Is this the same as this? Yeah. Let me ask you this. How many terms do you see, the way it's written right there, how many terms do you see? A lot of us said 1, some of us said 2. Let me try this. How many terms do you see here? 2. So here, for sure, there's 2 terms. Because terms are separated by what? Addition and subtraction. But multiplication glues everything together as what? 1 term. So division is a form of multiplication. So this denominator is glued together with the numerator, like looking at it like this. So it kind of feels like 1. But at the same time, you have this happening. It's 2. Okay, so it's 2. Those details are important in your growth from all the experience and problems that you're going to do. But if you right now don't see that this is 2, that's okay for now. You'll learn to develop to see it. Okay? All right, so let's go back. Any questions on this one before we move on to our next one? And after our next one, we'll eat. Okay, so let's go to our next example. Oh, and real quick, just so you know, I had 2 imaginary solutions and 1 double root real solution. Okay? 4 total. 2 real, 2 non-real. The one that was real was just double counted. Okay? So let's move to this one. Wait, this is the exact thing, right? It's just showing the work for it. Yeah. Alright, so we'll do this next one right here. Yeah, what are the real and imaginary solutions for, and I will rewrite this, guys, because those of you in the back, it's a little hard to read that. It's x squared minus 1, x squared plus 4. This one's a big, important problem. A lot is going on in this one. Here we go. Solutions. Find the solutions. We need to get it in what form? Not standard form necessarily, factored form. Factored form, okay? Here we go. Some people on 5th period this morning said we should distribute this all out and find the standard form. I think a couple of you said that just now. The standard form would only help us with graphing. You know what I mean? As far as when to go up, when to go down, when to, you know what I mean? All that balancing stuff. But it doesn't help us with this. Solutions, set equal to 0, solve for x. A way you can remember that, when you see the word solutions, set it equal to 0 and solve, let's pretend that all this means e or ve, solve for x. I don't know, I'm just trying to do something so that you can remember it, okay? So when you see solutions, haha, he was a dork, but he made us laugh, oh, I gotta solve for x. Okay, that's what I want you to see. Now look at this. For bonus points, what 3 words am I thinking about when I underline that? Say it out loud. Don't be afraid to make a mistake. 3 words. 3 words.
No, it's all the words that mean
Oh, great is coming back.
3 words. Be loud or you're not going to get the points. I'm hearing it.
Great is coming back.
Nope, I'm hearing it. Difference of squares.
Oh, I was not thinking that.
Yeah, it's been. This was last unit. You need to bring that back. I promise you. Otherwise, you're going to be taking forever on some of these, just scratching your head of what do I even do next. Difference. They call it a difference because it's subtracting. Right? So a difference of squares means that it will be that. This is huge, guys, what I'm showing you right now because it will finish the notes for today. I'm going to bring this back from last unit. what are my two factors going to be? X plus 1, x minus 1. If you don't know that, if I square root, this is why they're called a difference of squares. If I square root this, it will give me x, which is what you see. If I square root this, it will give me 1, which is what you see. Okay? Now look. What three words would I say with that? Sum of squares. But why do I not do anything with sum of squares? You can't do sum of squares. Exactly. Why? Let's look. I'll show you why right here. Because if I did this, x squared would be x. The square root of 4 would be 2. I would have x squared minus 4. And some of you are saying, well, Mr. Gomez, look, you have to make this positive because that's a positive. If you did, check this out. This would give you x squared. The last would give you 4. But now I just created 2 and 2, a b term that was not even there. That's one way you can remember sum of squares do not exist. Okay? The best way I think you should remember is this. If you set this equal to 0 and solve for x, algebra 1, here we go. What would I do? Subtract 4. Uh-oh, and there it is. What would I do here? Let's see if you didn't forget. What would I do here? This is rule 2, solving square roots. What would I do here? Trying to hear those words. It would be imaginary, but we know it would be 2 answers. Look, when I take a square root, you need to remember this. A lot of people will forget it. It's going to be 2 answers. It's going to be the positive and negative answer. That's if this power is 2, 4, 6, 8, any even number, then you're going to have a positive and negative there. You'll see that with the harder ones today, okay? When people forget, they'll forget half of their answers. Okay? What's the square root of negative 4? 2i. Because the 4 comes out as a 2, the negative 1 comes out as a I. So, here we go. Someone asked me this last class, and it was a really, well, I was seeing if you could ask me it. Right here, this is the fully factored form. Here's another example. Even though this is not all the way down to 1, this 2 right here, it's still a fully factored form because, come on, you can't factor that because there's no sum of squares. You can't factor it, but you can still solve from that spot to get you your answers. So factoring, you're done. Solutions, you're not done. So you could do the quadratic formula, or you could just do what I did. That one's what I just did is a lot faster than the quadratic formula. Because you're just doing the plus or minus square root of what you have on the right side. Yep, so here we go. We have a plus or minus 2i. Anyone, guys, what's the answer to this factor? Negative 1. What's the answer to this factor? 1. Uh-oh. How many times did I cross the x-axis? 2. You will only cross where it's real. You will not cross. There's weird squigglies and different things going on that we're not going to learn by hand. But this accounts for other stuff going on. It's lunch.